Okay, sorry I didn't have a video for the remaining questions, but since I had an existing video for the last question in the review, I wanted to create one for at least for the first question, the graphing question. So this question asks us to graph the exponential function 5/3 raised to the x and the logarithmic function log base 5/3 of x. And so in each case here we raise the base 5/3 to these exponents, -3, -2, -1, 0, 1, 2, and 3. And then you can see, hopefully, that when we raise 5/3 to the -3, that gives us 3/5 to the +3, because we take the reciprocal because of the negative exponent. And 3/5 to the third power is 3 cubed, or 27, over 5 cubed, or 125, and you divide that out and you get approximately 0.216. And similar results occur when you divide, or when you rather raise 5/3 to the -2, that's 3/5 to the +2, which is 3 squared equals 9, and 5 squared equals 25, and 9 divided by 25 is 0.25. And then 5/3 to the -1 is 3/5 to the +1, and that's 0.6. And I said approximately, but actually all of these, none of these should be approximate values. These are exact values, all of these three. Now these, on the other hand, are approximate values. 5/3 to the 0, of course, anything to the 0 is 1, and but 5/3 to the first power is 1.6666, never terminated, never terminating. 5/3 squared is 25 over 9, which as a decimal is 2.77 with the 7, never terminating. And 5/3 cubed is 125 over 27, and that's approximately 4.63. It's 4.62, and I don't really remember what comes after that, but that's a good decimal approximation. So these are the points, the x's and the y's, for the exponential function. Now, to graph the logarithmic function, all you have to do is write in this column, in the x's column, in the x column, all the values that you have here in the y column, in the function value column for the exponential. And then in the last column, the function value, the y values of the logarithmic function, you just copy this column, the x's. So the x's and y's trade places for all of these. Now when you plot those points, then you will have this graph here. So when x is, this is the exponential function right here. Let me ask my program to plot that. Okay, so that is the exponential function right there. When x is -3, then y is 0.216. So this is 0.1, 0.2. This is ever so slightly above that. When etc., when x is 0, y is 1, and so on. And then after you swap the x's and y's and plot the logarithmic function, okay, then you have a mirror. These two mirror across the diagonal line running through the graph, the 45-degree angle line running through the graph, which is also, as I mentioned in class, it's also the function f of x equals x, or y equals x, the identity function. And now one last thing, the program I use does not have the ability to change the base of the logarithm that it's graphing, so you have to use the change of base formula. So I use the natural log of x divided by the natural log of 5/3, and you can see that gives me this exponential function that mirrors, that gives me this logarithmic function that mirrors this exponential one. Okay, so that's the 5/3 to the x and log base 5/3. Here is 3/5. Now 3/5 is just the reciprocal of the 5/3, and you'll only be asked one or the other, not both. But you should be prepared to graph either one, to sketch a graph of either one. And for this function, if you were doing both of these as practice, you would see that the columns here, the inside columns, the function values here get flipped vertically. So what was down here raised to the third power, 5/3 raised to the third power, was 4.63. It's now up here, because 3/5 to the -3 is the same thing as 5/3 to the +3. And so you have all the same values you did before, you just have them in the reverse order. So instead of 0.216 being up here, 0.216 is down here. And instead of having 2.78 here, 2.78 is up here, and etc., etc. And then once again, the values that you get in this column, you simply repeat in this column, and the values you have for your x's here, you repeat as your y's here. Okay? And once you do that, this is what your graph is going to look like. Your exponential function is right here. It's a decreasing exponential function. Okay, but just as for any exponential function, anything raised to the 0 is 1, so it has a y-intercept of y equals 1. And then the logarithmic function, once again, for me to plot this in my program, I had to use the change of base formula. So this is natural log of x over the natural log of 3/5. But again, you can see that these two functions mirror one another across that 45-degree angle line. And I think I'll just put that up there just for greater visual effect. You can see that there is a reflection across this line of these two functions. Okay, I think that's all I've got to say about that, and I'll get the solutions to or the answers rather, to the other questions up as soon as possible, and get this video loaded as soon as my internet will allow.